An electrostatic generator, or electrostatic machine, is an electromechanical generator that produces static electricity, or electricity at high voltage and low continuous current. The knowledge of static electricity dates back to the earliest civilizations, but for millennia it remained merely an interesting and mystifying phenomenon, without a theory to explain its behavior and often confused with magnetism. By the end of the 17th century, researchers had developed practical means of generating electricity by friction, but the development of electrostatic machines did not begin in earnest until the 18th century, when they became fundamental instruments in the studies about the new science of electricity. Electrostatic generators operate by using manual power to transform mechanical work into electric energy. Electrostatic generators develop electrostatic charges of opposite signs rendered to two conductors, using only electric forces, and work by using moving plates, drums, or belts to carry electric charge to a high-potential electrode. The charge is generated by one of two methods, either the triboelectric effect or electrostatic induction. Description: electrostatic machines are typically used in science classrooms to safely demonstrate electrical forces and high-voltage phenomena. The elevated potential differences achieved have been also used for a variety of practical applications, such as operating X-ray tubes, medical applications, sterilization of food, and nuclear physics experiments. Electrostatic generators such as the Van de Graaff generator, and variations as the Pelletron, also find use in physics research. Electrostatic generators can be divided into two categories depending on how the charge is generated. Friction machines use the triboelectric effect. Influence machines use electrostatic induction. Friction machines history: the first electrostatic generators are called friction machines because of the friction in the generation process. It may not actually have been rotated during use and was not intended to produce electricity, but inspired many later machines that used rotating globes. Isaac Newton suggested the use of a glass globe instead of a sulfur one. Francis Hawksby improved the basic design with his frictional electrical machine that enabled a glass sphere to be rotated rapidly against a woolen cloth. Generators were further advanced when Professor Georg Matthias Bose of Wittenberg added a collecting conductor. Bose was the first to employ the prime conductor in such machines, this consisting of an iron rod held in the hand of a person whose body was insulated by standing on a block of resin. In 1746, William Watson's machine had a large wheel turning several glass globes, with a sword and a gun barrel suspended from silk cords for its prime conductors. J.H. Winkler, professor of physics at Leipzig, substituted a leather cushion for the hand. During 1746, Jan and Janus invented electric machines made of plate glass. Experiments with the electric machine were largely aided by the discovery that a glass plate, when coated on both sides with tinfoil, can accumulate a charge of electricity when connected with a source of electromotive force. The electric machine was soon further improved by Andrew Gordon, a Scotsman and professor at Erfurt, who substituted a glass cylinder in place of a glass globe, and by Giesing of Leipzig, who added a rubber, consisting of a cushion of woolen material. The collector, consisting of a series of metal points, was added to the machine by Benjamin Wilson about 1746, and in 1762, John Canton of England improved the efficiency of electric machines by sprinkling an amalgam of tin over the surface of the rubber. In 1768, Jesse Ramsden constructed a widely used version of a plate electrical generator. In 1783, Dutch scientist Martin van Marum of Haarlem designed a large electrostatic machine of high quality with glass discs 1.65 meters in diameter for his experiments. capable of producing voltage with either polarity. It was built under his supervision by John Cuthbertson of Amsterdam the following year. The generator is currently on display at the Tellers Museum in Haarlem. In 1785, Reuland constructed a silk-belted machine that rubbed two grounded tubes covered with hair fur. Edward Nen developed an electrostatic generator for medical purposes in 1787 that had the ability to generate either positive or negative electricity. The first of these being collected from the prime conductor carrying the collecting points and the second from another prime conductor carrying the friction pad. The Winter machine possessed higher efficiency than earlier friction machines. In the 1830s, Georg Ohm possessed a machine similar to the Weimar machine for his research. In 1840, the Woodward Machine was developed by improving the Ramsden machine, placing the prime conductor above the disc. Also in 1840, the Armstrong hydroelectric machine was developed, using steam as a charge carrier. Friction operation. The presence of surface charge imbalance means that the objects will exhibit attractive or repulsive forces. This surface charge imbalance, which leads to static electricity, can be generated by touching two differing surfaces together and then separating them due to the phenomena of contact electrification and the triboelectric effect. Rubbing two non-conductive objects generates a great amount of static electricity. This is not the result of friction. Two non-conductive surfaces can become charged by just being placed one on top of the other. Since most surfaces have a rough texture, it takes longer to achieve charging through contact than through rubbing. Rubbing objects together increases amount of adhesive contact between the two surfaces. Usually insulators, e.g., substances that do not conduct electricity, are good at both generating and holding a surface charge. Some examples of these substances are rubber, plastic, glass, and pith. Conductive objects in contact generate charge imbalance too, but retain the charges only if insulated. The charge that is transferred during contact electrification is stored on the surface of each object. Note that the presence of electric current does not detract from the electrostatic forces nor from the sparking, from the corona discharge, or other phenomena. Both phenomena can exist simultaneously in the same system. Influence machines. History. Frictional machines were, in time, gradually superseded by the second class of instrument mentioned above, namely, influence machines. These operate by electrostatic induction and convert mechanical work into electrostatic energy by the aid of a small initial charge which is continually being replenished and reinforced. The first suggestion of an influence machine appears to have grown out of the invention of Volta's electrophorus. The electrophorus is a single-plate capacitor used to produce imbalances of electric charge via the process of electrostatic induction. The next step was when Abraham Bennett, the inventor of the gold-leaf electroscope, described a doubler of electricity as a device similar to the electrophorus, but that could amplify a small charge by means of repeated manual operations with three insulated plates. In order to make it observable in an electroscope, Erasmus Darwin, Wilson, C. Bonenberger, and J. C. Peclet developed various modifications of Bennett's device. In 1788, William Nicholson proposed his rotating doubler, which can be considered as the first rotating influence machine. His instrument was described as an instrument which by turning a winch produces the two states of electricity without friction or communication with the earth. Nicholson later described a spinning condenser apparatus as a better instrument for measurements. Others, including T. Cavallio, John Reed, Charles Bernard Desormes, and Jean-Nicolas Pierre Hachette, developed further various forms of rotating doublers. In 1798, the German scientist and preacher Gottlieb Christoph Bonenberger described the Bonenberger machine, along with several other doublers of Bennett and Nicholson types in a book. The most interesting of these were described in the Annalen der Physik. Giuseppe Belli, in 1831, developed a simple symmetrical doubler which consisted of two curved metal plates between which revolved a pair of plates carried on an insulating stem. It was the first symmetrical influence machine, with identical structures for both terminals. This apparatus was reinvented several times by C. F. Varley, that patented a high-power version in 1860, by Lord Kelvin 1868, and by A. D. Moore, more recently. Lord Kelvin also devised a combined influence machine, an electromagnetic machine, commonly called a mouse mill, for electrifying the ink in connection with his siphon recorder, and a water-drop electrostatic generator, which he called the water-dropping condenser. Between 1864 and 1880, T.B. Holtz constructed and described a large number of influence machines which were considered the most advanced developments of the time. In one form, the Holtz machine consisted of a glass disc mounted on a horizontal axis which could be made to rotate at a considerable speed by a multiplying gear, interacting with induction plates mounted in a fixed disc close to it. In 1865, August J. I. Toepler developed an influence machine that consisted of two discs fixed on the same shaft and rotating in the same direction. In 1868, the Schwedoff machine had a curious structure to increase the output current. Also in 1868, several mixed-friction influence machines were developed, including the Kunt machine and the Carré machine. In 1866, the Picker machine was developed. In 1869, Julius Smith received the American patent for a portable and airtight device that was designed to ignite powder. Also in 1869, sectorless machines in Germany were investigated by Poggendorff. The action and efficiency of influence machines were further investigated by F. Rossetti, Righi, and Friedrich Kohlrausch. E. N. Mascott, Reutte, and E. Buchotter also examined the efficiency and current-producing power of influence machines. In 1871, sectorless machines were investigated by Musaeus. In 1872, Rie's electrometer was developed and was one of the first antecedents of the Van de Graaff generator. In 1873, Laser developed the laser machine, a variation of the Holtz machine. In 1880, Robert Voss devised a form of machine in which he claimed that the principles of Toepler and Holtz were combined. The same structure became also known as the Toepler-Holtz machine. In 1878, the British inventor James Wimshurst started his studies about electrostatic generators, improving the Holtz machine. In a powerful version with multiple discs, the classical Wimshurst machine, that became the most popular form of influence machine, was reported to the scientific community by 1883. Although previous machines with very similar structures were previously described by Holtz and Musaeus. In 1885, one of the largest ever Wimshurst machines was built in England. In 1887, Weinhold modified the laser machine with a system of vertical metal bar inductors with wooden cylinders close to the disc for avoiding polarity reversals. M.L. Lebes described the Lebes machine, that was essentially a simplified Voss machine. In 1893, Benedict patented a machine with the structure of the Wimshurst machine, but without metal sectors in the discs. This machine is significantly more powerful than the sectored version, but it must usually be started with an externally applied charge. In 1898, the Pigeon Machine was developed with a unique setup by W. R. Pigeon. On October 28 that year, Pigeon presented this machine to the Physical Society after several years of investigation into influence machines. The device was later reported in the Philosophical Magazine and the Electrical Review. A Pigeon machine possesses fixed inductors arranged in a manner that increases the electrical induction effect. The essential features of the Pigeon machine are 1. The combination of the rotating support and the fixed support for inducing charge, and 2. The improved insulation of all parts of the machine. Pigeon machines are a combination of a Wimshurst machine and Voss machine, with special features adapted to reduce the amount of charge leakage. Pigeon machines excite themselves more readily than the best of these types of machines. In addition, Pigeon investigated higher current, triplex, section machines with enclosed sectors for this type of machine. Multiple disk machines and triplex, electrostatic machines were also developed extensively around the turn of the 20th century. In 1900, Tudsbury discovered that enclosing a generator in a metallic chamber containing compressed air, or better, carbon dioxide, the insulating properties of compressed gases enabled a greatly improved effect to be obtained owing to the increase in the breakdown voltage of the compressed gas, and reduction of the leakage across the plates and insulating supports. In 1903, Alfred Wehrson patented an ebonite rotating disc possessing embedded sectors with button contacts at the disc surface. In 1907, Heinrich Wommelsdorf reported a variation of the Holtz machine using this disc and inductors embedded in celluloid plates. Wommelsdorf also developed several high-performance electrostatic generators, of which the best known were his condenser machines. These were single-disc machines, using discs with embedded sectors that were accessed at the edges. Modern electrostatic generators had a fundamental role in the investigations about the structure of matter, starting at the end of the 19th century. By the 1920s, it was evident that machines able to produce greater voltage were needed. The Van der Graaff generator was developed, starting in 1929, at MIT. The first model was demonstrated in October 1929. The basic idea was to use an insulating belt to transport electric charge to the interior of an insulated hollow terminal, where it could be discharged regardless of the potential already present on the terminal, that does not produce any electric field in its interior. The idea was not new, but the implementation using an electric power supply to charge the belt was a fundamental innovation that made the old machines obsolete. The first machine used a silk ribbon bought at a 5-and-dime store as the charge transport belt. In 1931, a version able to produce 1 million volts was described in a patent disclosure. Nikola Tesla wrote a Scientific American article, Possibilities of Electrostatic Generators, in 1934 concerning the Van der Graaff generator. Tesla stated, "I believe that when new types of Van der Graaff generators are developed and sufficiently improved, a great future will be assured to them." High-power machines were soon developed, working on pressurized containers to allow greater charge concentration on the surfaces without ionization. Variations of the Van der Graaff generator were also developed for physics research, as the Pelletron, that uses a chain with alternating insulating and conducting links for charge transport. Simplified Van der Graaff generators are commonly seen in demonstrations about static electricity, due to its high voltage capability, producing the curious effect of making the hair of people touching the terminal, standing over an insulating support, stand up between 1945 and 1960. The French researcher Noël Félicie developed a series of high-power electrostatic generators, based on electric excitation and using cylinders rotating at high speed and hydrogen in pressurized containers. EWICON, an electrostatic wind energy converter. The EWICON has been developed by the School of Electrical Engineering, Mathematics and Computer Science at Delft University of Technology. Other than the wind, it has no moving parts. It is powered by the wind carrying away charged particles from its collector. Fringe science and devices. These generators have been used, sometimes inappropriately and with some controversy, to support various fringe science investigations. In 1911, George Samuel Pigott received a patent for a compact double machine enclosed within a pressurized box for his experiments concerning radiotelegraphy. and anti-gravity. Much later, a machine known as Testatica was built by German engineer Paul Suisse Baumann, and promoted by a Swiss community, the Methanothans. Testatica is an electromagnetic generator based on the 1898 Pigeon electrostatic machine, said to produce free energy, available directly from the environment.